Hello, everybody. I'd like to welcome you to my YouTube channel. This is Steve, and on this channel, you will learn about programming the Commodore 64 in either BASIC or assembly language. The point of this series is to go over a project series that I will be releasing here real soon, which will include up to about 18 videos, teaching you how to write your own assembly language routines all the way up to some kind of a mini game. In this series, we are going to be discussing the Commodore 64 game project, and this was originally created back in 2020, last year, during this pandemic. Obviously, a lot of people ended up working at home, and I even got married myself. So let's continue. The project purpose. The purpose of this video is to provide a series of projects for both the new and seasoned programmer that could be used to create a simple game. The techniques used here are likely advanced, but hopefully this guide should be easy enough for a beginner. History of the project. Many of the techniques within the heart of this program were the result of a lead developer, Siggy, that came aboard the machine language project several years ago. Other coding segments were extracted from the game Supernatural. A big thanks to the Highlander for providing amazing tutorial videos for that game. More recently, newer additions were created by the admin of this channel. Now, some sound advice. One of the best things I've learned in life is to finish what you start. We begin by working on one task at a time until completion and then move on to the next. You will accomplish great things which will hopefully allow you to create your very first Commodore 64 game. So here you see a disclaimer. I'm not going to read the whole thing, but essentially if you publish a game or get ready to publish a game, please contact me. And also these terms can change, so it may take me longer than necessary to get videos out. Okay, you can also subscribe. This is kind of a given to my YouTube channel. I appreciate that. And here's my Facebook page. Now I wanted to really make this really important note. Even though we have YouTube to communicate as a channel, I prefer this project to be communicated directly through my Facebook page. And that's exactly why I put the link here, and I'll put it in the description below so you'll have that. This will allow me to have more engagement and be able to work with you real time instead of waiting for somebody to comment. Well, if you comment on my Facebook page, I'll be able to see it right away and not have to wait. Project code downloads. Finally, the game will utilize Github for repository project saves to allow downloads of the project examples. It will be necessary to have your own GitHub account to access the files, and I provided my GitHub link here. Here's some good books to also learn for those who want to learn about assembly language. There's some others I'd like to put up here too, like Jim Butterfield's book, but these are the most preferred. Mapping the Commodore 64, a lot of people know about, and these other ones are just other ones I have. What you will learn. Each project example will continue to build upon the previous one as you begin to pick up new skills. The following screen will demonstrate what is contained within each one. As an example, you will first learn how to design a map, save it, and get it placed on the screen. These are the steps I'm talking about. Then you will learn about scrolling the map, placing a sprite animation, adding gravity, collision detection like poles, balls, and so on, water animation, debug messages, enemy attacks, score counters, player death, new levels, title screen, sound effects, music, and so much more, which is pretty much everything you would see within a Commodore 64 game, a really good one. And at the end result is to have a nice game engine you can use to branch off and create your own work of art. Game project overview. These projects, when completed, will result in a mini game that contain, and kind of as a highlight here, game map loaded to screen, full screen scrolling map, sprite movement, animation, walking, punching, jumping, and so on, background animation, sprite collisions, wall, pole, other sprites, title screen, raster colors, animation, sound effects, and music. Project Series Overview. The next section will cover all the projects from 1 to 18 that will be published to my YouTube channel as time allots. I have already have a global concept of how I desire to complete this series. Although I may not get my actual game done during this time, I will, however, continue to release the new videos as often as I can, as I mentioned earlier. For each project example, I have listed various things you will learn about. Further ahead, you will see the game subroutines used by all 18 projects and a definition of what is contained within each. I've also provided a few tips about collision detection, raster examples, and creating your own vice snapshots so you can add to your own projects. You will also see a quick overview of CharPad or CharPad and the CBM PRG Studio Sprite Editor. The actual projects will likely evolve to eventually include SpritePad. Another reminder is to, again, join my Facebook page. Put it out there again in case people have forgotten about it at this point. But yes, the Facebook page is very important. So what you're going to see is about 18 slides here showing the different segments of each individual project. And you can actually use these to start creating your own stuff, but this is just kind of as far as I've gotten. And the whole purpose is to help you put together with these routines and these assembly language modules to be able to create your own game somehow out of this, or maybe just a mini project. And I'd like to see, what you come up with. So here you're going to now see the projects from 1 to 18. I'm just going to quickly read through these. Project 1 is, I kind of reviewed, displaying a game map, and it's going to have banking memory, copy and generate a ROM character to memory, setting screen colors, clearing the screen front and back, building a level, drawing the map. Project 2 would be scrolling the game map. Okay, so this is going to have detection against walls when scrolling, joystick controls, player routines, these are the states, screen scrolling, which is joystick controlled, sprite routines, used to position the map, X, Y screen scrolling coordinates. Project 3 is sprite position on the map. Sprite is enabled, turn on, sprite colors are set, sprite is placed at XY screen coordinates position. Project 4 is move sprite around the map, sprite walking left-right animation, sprite can move left, right, up and down, sprite detection against walls. Now project number 5 is other sprite animations, which I've done this too. Sprite punching left, right, sprite kicking left and right. Project number 6 is going to be game gravity. A sprite falls when walking off a ledge. Animation for falling sprite. Sprite can land on floor below. So there again, there's the gravity right there. Project 7 is climbing up. Sprite can climb up, down poles. Detection when sprite falls off a pole, that gravity. Screen scrolls up when sprite climbs to the top of the pole. Project number 8 is the jumping state. Sprite can jump up. Sprite can jump left and right. Sprite can land on poles after a jump. Project number 9 is new sprite animations. Sprite can swim left and right. Sprite water detection. Project 10 is screen animations. Water animation, pole animation, kind of like the barber effect. Detection for landing in the water. Sprite left, right, water animation movement. These are being used by rasters, by the way. Project number 11 is debug messages. Hexadecimal display of game parameters. Position of text messages on the screen. Project number 12 is enemy attacks. Enemies chase the player. Enemies can attack the player. Player can attack the enemies. Now, I've also included an advanced section here if I have time. These possible implementations would include sprite layers, single, multiple, boss, like 3 sprites on top of each other, kind of make a gigantic sprite, so to speak. Enemies shoot at player and can attack. Project number 13 is the score counter, a game scoreboard. Scoreboard is displayed below the map. Player's death. Player dies after losing so many lives. Player death animation. Project number 15 would be new levels, like new maps. Game levels displayed after completing level 1, and so on. New level generation demonstrated in CharPad. Difficulty increased for each new round. Project 16 would be game title screen. display title screen before the game begins, animation of sprites to make it interesting, raster effects, colors, and so on. Project 17 is sound effects. Sound effects can exist for player to enemy battle, punching, kicking, and so on, river animation maybe. Project 18 is the game music. This is going to have music playing in the background, and it can switch tracks based on states. So here's an example of what the display will look like. I may end up changing the map later, but this is just a simple game map for now. You can see down below it's got its own screen panel. This is originally taken from the machine language project, but I have full control over what I want to put at that bottom. Now I'm going to go over what are called subroutines. These are kind of like the functions of the game. I won't read every single one because there's a lot in here and it would take time, and it's already been 12 minutes. We will begin to review the subroutines included in the project. These are listed as follows: macros, registers, collision detection, raster interrupts, main game routines, sprite setup and event states, screen memory setup, scrolling, sprite routines. And then we talked about macros on the first one. And here's some of the macros. You can see there's load pointers. Essentially, these are using 0 pointer locations to make it easier to copy segments over and transfer data in memory. Now we're on to registers. These are called the VIC registers for the Commodore 64. It has a series of many registers that are used to control things from like color to sprite positions on the screen. You can see them kind of all listed down here, and even some of the banking and stuff like that. And on the other side there, I kind of separated those, even those are not VIC. Those are just other additional registers that are used by the game itself, including the colors. Collision detection, you can see the man kind of standing against the wall there. Now these are the collision detection routines. You can see everything from moving left, right, down, up, under. And I think I have an example here I'll show you later, but really it's kind of like a box around your player, and it's detecting what is going on outside of that box. And this is also called delta. So as the sprite moves forward, which I think I'll explain about further later here, the delta will pass over after so many different pixels. It will have pixels and it will pass into a tile. You'll see it here in a minute. So here it is. Here's a tile collision example. You can see the sprite kind of ballooned up here and a tile wall there. And here's what I'm talking about. So tile delta checks. When a sprite bumps against a tile in any direction, the data is checked, which is the delta, to see if the sprite is touching any of the tiles from 0 to 3. Below is an example of a tile. Deltas range from 0 to 3, tiles left to right. So you see 0 is like when he's first entering the tile. I'm just going to use my mouse here for a minute. Over here, he's like this, pretend the sprite's over here. He's first moving into the tile here. So he's going to be at the 0 location here. This is all the 0 tile area. And it's going pixel by pixel here, you can see. And as he gets past 0, now he's going to hit 1. So now he could be bumping up against something. And then 3 means he went all the way through it. Now, keep in mind, a sprite isn't going to actually pass through a tile. This is just showing an example of how you could do that. If you were basically trying to bump up against something and you need to reach your hand out or something to touch deeper into that, you could use a delta for that. This example is being done because in the original machine language project, there was a ladder that was created. And when you needed to walk halfway on the ladder and not end up bumping into the tile next to you. So he could kind of like be halfway on the ladder, maybe kind of portionally into the ladder here, while there could be like a tile here for number 3 that's detected. Now anything after 3 means he left the tile. There wouldn't be no more detection going on. So on the side there you can see deltas range from 0 to 3 left to right. The sprite cannot pass through the tile till it's reached the tile 3 delta, as I explained. This is used to see how far the sprites move through a tile. Raster interrupts. So here's some of the subroutines for the raster interrupts. Again, I'm not going to try to read them all, but these are just the ones to kind of get everything up and running from the game timing and stuff like that, and glitch catching and stuff like that to make sure that the scrolling is looking really good. And it's also got the timers at the bottom there, including some of the ones I've added myself. Now we're on to raster interrupts here. So raster interrupts occur when a horizontal line is interrupted and the action is taken at that specific line. A TV set typically casts a horizontal beam that scans your television display from left to right. The NTSC American screens contain 262 horizontal lines. The European PAL contained 312 lines. Only 200 of these lines are part of the visible display and updated every 60 seconds. And as a raster moves down the screen, you can set an interrupt to do something. Like if, let's just say, I know I wasn't going to talk much about it, but let's say raster was scanning at a stop down here somewhere, and you wanted to check this line, you could use this to split the screen. And that's what I did in that game example. I mean, original machine language project has the bottom screen split. You could also do this with multiplexing sprites. You could multiplex a sprite, and as a result of it, you can duplicate the sprite. Here's horizontal scan lines as an example. Below is an example that demonstrates color lines, rasters, being accessed on a typical display, such as a monitor or television set. The Commodore 64 allows you to control interrupts on your display using register D012, which is decimal for 53266. Main game routines. And here's some of the subroutines for the main game, which again you'll see in that GitHub project. You've got the timers and the joystick and the character set copying. And here's the main routines. These ones, basically the first one is kind of starting off the big screen, banking memory, setting up the sprites, character map, and so on. Sprite setup and event states. So here's some of the player routines, subroutines for the game. These are the movement of the joystick up and down. You can see move player left, right, and all that. And also you can see player states. Now the player states are determining if a player is not moving, he's idle. If he's walking, he's walking. If there's a rope, you're going to use the rope one, jumping, punching, kicking, floating, and swimming. And you can continue to add them as your project grows. Screen memory setup. So the screen memory examples here are about swapping a screen. So you're moving between screen 1 and screen 2. It's called buffering because the Commodore 64 isn't fast enough to display something and keep it on the screen. It's faster, it's more efficient to build it on the back end, so to speak, and then you move it on the front when you're ready. And this saves a lot of raster time as well. And then the fetch line address here is going to just check the screen data to see what's in those locations. I know I'm kind of going into some examples here. Display bytes, these are those examples of the hexadecimal text displays. Clear screen is pretty self-explanatory. RAM should be explanatory, and draw lines or just draw lines on the screen. Now we're into scrolling. For scrolling, you're first going to load a level on the screen. And this is going to be loaded from character or CharPad's binary files. And then you're going to draw it. Now we're going to be using 4x4 map, which is essentially tiles arranged side by side. Tiles are kind of thinking like those little characters on your screen. And I wrote here, there's 10 tiles to a row. The height stretches 100 tiles across and 49 down. And you can alter that for your own projects. And then we have the X, Y register, which you'll see that in code. So I just threw it on here, and then draw on tile. Now the scrollings are going to be a little hard to see here. I try to get them all in one place here, but essentially what these are doing is there's an update scroll going on that checks the up, down, left, right movement, and when it detects something there, it is able to scroll the screen in that direction. The shift characters are shifting the characters on your screen as it's scrolling to keep track of those. The colors are being shifted left, right, up, down, and all that. And then you got the buffers, the back buffers I talked about, all the directions for those. And you even got something called a vertical buffer, which originally was used by Seagate to catch those, I forget that line thing that he was talking about. There's like this glitch, he calls it a glitch catcher. Basically catching this line that's kind of interrupting the display. And you'll see it on some games. It kind of flickers around on and off. Sprite routines. And the sprite routines we're using here, these are going to be really importantly taking the sprite's position, the sprite itself, I believe it's 24 by 21 or 21 by 24, and then it has to match an 8 by 8 location. So there's some math being done to make sure that when a sprite moves, it can detect a tile on the screen. And you can see the move left sprite, that's going to actually move the sprites in those opposing directions. And then you got the animation, set sprite, and initializing. Those are basically just those frames to create the movement of the character sprite on the screen. And here's an example of the design map for screen memory. This would actually have been, this was taken from Project 1. In Project 1, you'll see me, it's just a scrolling map. I show you how to scroll it around horizontally, vertically, left, up, or down. See 64 tools needed. Several tools are needed to design a map, create, load sprites, and run your project example. CharPad, SpritePad, and Vice. Now, I mentioned earlier, I'm not going to really lean on SpritePad, but it is available to us. I'm using the character sprite editor in CBM PRG Studio instead. But you can use it if you want. Game map construction. The game map screen has been created using the tool CharPad by Subchris Software. As I mentioned earlier, the maps can be 4x4, 100 by 49 in height, so on. Each tile contains pixels that are 4 width and height, and I give the measurements here if you want to take a look at those. If I'm off on the measurements, feel free to throw me a comment or something. Many of the tiles are direct extractions from other games, so a lot of the examples I'm using here are I've basically modified and taken other things from games I've liked, like Metal Warrior by Lacione, Turrican, Robocop, and some other designs. Including the sprites, I've done the same thing with sprites too. I've pulled many of them from Indiana Jones. There are 4 total CharPad binary files needed for the project, and this is a given for anybody who knows this. That's the character set attributes, tile set, and the map. Important to know this, which you'll see about in those example videos, because if you exclude any one of these, you may lose your color, you may not get your map to show up, and so on. Here's an example of CharPad, and this is just an example of my map. You can see here that it's got the tile editor, which is basically just pulling these tiles here. And then you've got the map editor, as I mentioned, is 100 width and 49 in height. And over here, of course, these are the attributes I was talking about. They're called the materials here, but they're actually attributes being used, color attributes that are being masked to receive the data to the screen. Now, the sprite editor, as I mentioned, it's included with CBM PRG Studio. A cool thing about using the CBM PRG Studio editor is that it comes complete with its own sprite editor. Although you're welcome to use sprite editor to design them, as I mentioned. The sprites in this project have been designed using the sprite editor and receive imports from various games, mentioned Indiana Jones, and modified to fit the game. The editor can export them from a binary file, set up multicolor sprites, has built-in tools to flip, shift, and rotate them, and all the other stuff you see here. You basically can import and export your own sprites. Okay, now this is an addition I added for this, for people who may not know this. Vice does exporting and importing of your sprites. You can basically take sprites that are being run in Vice Simulator and you can put them in your project. And here I'm saying sprites can be imported directly from any Commodore 64 game of your choice. Just load the game in the Vice C64 emulator. In the Vice window with your game running, you click on Snapshot and you choose to save snapshot image. When that box is open, you're going to name the file and make sure it has the extension .bsf by snapshot. Then inside of SpritePad, open up the File menu, choose Import Export, choose Vice Snapshot, import sprite data. When the Import Snapshot window opens, you're going to select a button called Select Snapshot File. And when a new window opens, I'll look for the location folder where you saved. You'll see the VSF file there. And after selecting the file and clicking the Open button, you will see the bitmap in the window above. After you select a video bank and click on it, okay, you'll get the OK screen. It appears inside of SpritePad where you can save it and import it into your game project. You may also need to search through the video bank memory to see where it exists in the current game. And in my example here, I loaded up the game Pitfall 2 in Vice. I'll show you the example here, but you're going to see this, and I'll try to put this into one of the projects so you can see it step by step how it works. But here you can see I took what was from Pitfall 2, and I imported it directly into SpritePad. And here, down here, this is the snapshot that's used here, and you can just go through these options until you find the right character data showing. or the right sprite data showing up here. Like if you put here and there's nothing in 0, you won't see nothing but garbage. Now, really importantly, you can use this video as a reference for your projects. The C64 Brain game project series is going to be referenced time and again whenever you need to learn about subroutines variables, because I gave definitions of what they're about in here. And it saves you having to scroll through all your code too. The guide was created to show you all the subroutines used in my current project, and you can use these whenever you're working on that specific routine and need to debug it or even expand it for your own use. I was going to include all the variables too, but that would bloat this first introductory video be quite excessively long. So it's been shortened for brevity. I personally enjoy meeting new people, subscribers, and like hearing about your stories and experiences with the Commodore 64, and I'm very genuine on that. Yes, I like learning from new people, and I just enjoy meeting with people. I'm a people person. And finally, thank you for watching. I want to personally thank you for watching this series, subscribing to this channel, and subscribing to my Facebook page, very important, and just being here today. It's people like you that keep the Commodore 64 alive after all these years. You can also share this video with your friends, family, anyone who finds it interesting to create their own games and projects for the Commodore 64, and I highly encourage that. You guys. Hi everybody, this is Steve. I want to thank you for watching the Commodore 64 game project, which will include up to 18 plus videos. I'm looking forward to getting your feedback on the Facebook page. You're welcome to comment on YouTube too, but the main project information again will be held on the Facebook page for C64 Brain, which I'll include the link in the description. And I hope you guys enjoyed the session. Sorry I was away for a while, but the good news is I've got some videos on the way and I'm back for who knows how long, but we'll see how it goes here. Anyways, thanks again. I appreciate everything, and you guys have a great night, and take care.